Hello, Mr. Mailer here, your online math teacher, and welcome to my channel. Today we're going to be continuing my series on exponential and logarithmic functions, and in particular, today we are going to focus in on exponential equations. My worksheet says both, but we're going to punt logarithmic equations to the next video. So if you want to learn about exponential functions equations, stay here. So let's get going. And remember, as always, smash the like button if you enjoy my content or it helps. So, these first problems I have here, example 1, I want you to see if you can solve these on your own without really doing much of anything. So pause video, see what you come up with. Okay, ideally you might have thought to do the following in these problems. In A here, you might have recognized 125 is really just 5 to the cube power, which means x had to be 3. And in B, you just set the exponents equal to each other. So 2x is equal to x plus 1 to get x equal to 1. And note, the reason we can do these is because these exponential functions are one-to-one functions. So we're guaranteed that these are the only solutions we're getting right now with these. So you can't always do a trick like this. Most of the time you can. But these are very special cases. And it was easy. If we had something that was different, like maybe 5x to the 160 power, you can't write in a nice way 160 as 5 to some power, so we wouldn't be able to do a trick like an A. So we need a more reliable approach instead of just getting lucky. So here's some guidelines for how we're going to do this. Your goal is going to be to isolate the exponential expression on one side of an equation. So kind of like in the past, you would start by trying to isolate x to solve things. You're going to isolate the exponential expression. Then you're going to take the logarithm of each side and use the laws to bring down the exponent. And sometimes there's going to be a very clear logarithm base to use. Sometimes there won't be. You can usually get away with almost any base. Some will make your final answer look a little bit nicer than others, though. And then final step, once you've gotten that exponent down, because it's usually where your x is hiding out in, just go about solving for it. So let's look at example 1 here. If I have 5 to the x plus 3 power is equal to 7, I've already have my exponential expression isolated on one side, so I can jump right to step 2. And you might tell yourself, okay, since this is 5 to some power, I'm going to use a base 5 logarithm. And if you do that, then the left-hand side is log base 5 of 5 to the x plus 3, and the right-hand side is log base 5 of 7. But that left simplifies by our properties of logarithms to become just x plus 3. And then that's equal to log base 5 of 7. And then to isolate x, just subtract the 3 away to get a final answer of x is equal to log base 5 of 7 minus 3. Now, maybe you don't want to, if you don't feel like playing the game of picking an x base of a logarithm that's going to make it look the nicest, you can just always pick the same one in a lot of these questions. A common ones to pick are either your common logarithm, pun intended, or a natural logarithm, because it's the natural choice. Again, guilty as charged with the puns. So if I had chose the natural logarithm, my solution would have looked more like this. I would have a natural log around both sides to begin with, but instead of having bases cancel, I could use the law of logarithms to bring down the exponent in front. So x plus 3 would then be multiplied by the natural log of 5, and that would be equal to the natural log of 7. From there, you could divide over your natural log of 5, and then finally subtract over your 3 to get your final answer of x equal to the natural log of 7 divided by natural log of 5, all minus 3. So these answers both look very different, but they're actually the same. One way you could verify that they're the same is using a change of base formula, which I'll probably make a video on in the near future. But just because two things look different doesn't mean they are different when it comes to logarithms. But these are two different approaches. The benefit of the one on the right, your calculator probably has a natural log button, but it might not have a button that lets you do log base 5 if you want to find a decimal approximation. So the base doesn't really matter. There are advantages and disadvantages to each one, but let's continue with another one. So here, let's see if you can follow my step-by-step process. So try to isolate the exponential function and then see what you can do to bring it down. Okay, hopefully you tried A, and if you did, you hopefully divided by your 10 first to get e to the 3x is equal to 11/5. Then maybe you chose the natural logarithm again, and when you apply that to both sides, you get this natural log of e to the 3x is equal to natural log of 11/5. And then our properties of logarithms let the natural log cancel with the e essentially, because they're inverses, to leave you with 3x is equal to the natural log of 11/5. And then finally, to get the x by itself, you probably divided your 3. So, and again, you could have picked a different base logarithm and it would look slightly different, but you still have a nice approach. Similarly with B, you hopefully had the following, where you took the natural log of both sides, applied our properties of logarithms on the left to cancel, in a sense, your natural log with the base e there to get 5 minus 3x, and then it's just solving for x. Again, your answers are going to look different if you're picking a different base for them. Usually, if there's not one jumping out at you to use the common logarithm or the natural logarithm. I tend to use natural, but it's totally up to you. So these are some examples of things you can have. Another type of equation you might see is a quadratic type of equation. So by quadratic, I mean something that looks like e to the 2x minus e to the x minus 6 is equal to 0. Why is this quadratic? Because if I rewrite that first term with my exponent rules and make a clever little substitution by letting u be equal to e to the x, it looks like a quadratic equation. And if it's a quadratic, that means you can try to factor it to solve. You can use the quadratic formula if you don't see a factorization. Then you might use that new fancy approach that's not the quadratic formula, which is a supposed easier way to solve, which I might make a video on soon. But if you did that, you'd get the following factorization because it's the easiest way. You get u is equal to 3 and u is equal to negative 2 would be our zeros. And substituting back in our e to the x for u, e to the x is equal to 3, which means x is equal to the natural log of 3 is going to be one of our solutions. And then the second one is e to the x is equal to negative 2. That can't happen though, because we know negative 2 is not in the range of our function. So if you have to draw yourself a little picture of the graph to convince yourself negative 2 is not in the range. So this is not going to give any solutions. So that natural log of 3 is our only solution. Also, you saw how I use factorization there to solve my quadratic. We can solve a lot of other types of equations with factorizations too. So why don't you see if you can factor and find all the solutions to exercise 3 here. Okay, hopefully you paused the video and tried that, and if you did, you got the following factorization. X e to the x times in parentheses 3 plus x, and that's equal to 0. So just like our quadratic examples, you set each of those factors equal to 0. I set x equal to 0, and that just gives me a solution. I don't need to do anything. E to the x is equal to 0. Well, that doesn't have any solutions because, again, based on our picture, 0 is not in the range of e to the x. So we pick up nothing new. And then 3 plus x tells us negative 3 is also one of our solutions. So we have 2 solutions here. So these are some quick examples of ways you're going to solve all the equations for our exponential functions. So I hope you found this video helpful. And if you did, smash the like button and have an awesome day.